Okay, well, why don't we get started? I'm Paul Wormley, chairman of the Standing Committee on Information Technology and Architecture of the IGES Institute, and this webinar is a celebration of a 25-year relationship between the IGES Institute and the National Center for State Courts, in which we have collaborated over the years in a multitude of ways to improve information sharing across the criminal justice system. The IGES Institute and the National Center have been engaged in multiple projects together over the years, including a very important project to develop a advanced architecture for criminal justice information systems, which was published a few years ago. Many other activities. Our Court Technology Committee and my committee, the Technology and Architecture Committee, are collaborating with the National Center to bring together this webinar to you, and we will be discussing first of all, some of the theoretical foundations of this important issue of entity resolution, which has plagued the criminal justice system since the beginning of time. We have always had the problem of facing how do we bring together records from different systems and the repeated occurrence of records about people within the same system, and how do we bring these together so that we mitigate the risks of having wrong identifications or the absence of identifications, which can lead to both good and bad consequences, and depending on your point of view. But we have always had to face this issue, and we're fortunate today to have some of the advanced technologies that have been developed to help us with these issues. And what today we intend to do is to, once we describe some of the problems and challenges of this topic of entity resolution, is to give you some examples of how different agencies and organizations have solved the issue or attempted to solve the issue, and then talk a little bit about how to get started to improve what's happening in your agency or organization. And we're happy to have people representing the practitioner community and the technology community participating in this, because we're at IGES, we're firmly convinced that the technology service providers out there need to be paying close attention to this issue, and we know that the practitioner community wants to ensure that the decisions and policies that are developed around the solutions are accurate, fair, and just. So with that, we're going to proceed. I'm delighted to welcome the executive leadership of these two organizations to open this topic for you. First, I'd like to introduce Maria Cardialis, the executive director of the IGES Institute. Maria has a long track record and a distinguished career in the justice field, having worked as the CIO for the New Jersey Department of Law Enforcement before joining IGES, and she's been involved in IGES since the earliest days of IGES, working as a practitioner as well as a technologist involved in this field. And as in my humble opinion, I really have to describe Maria as the best executive director the IGES Institute has ever had. And so I'm delighted to have her welcome you. Maria?
Thank you, Paul. And I must owe Paul something, so everyone will see that as a witness. But I thank you very much for the kind words. And I very sincerely thank you and welcome you to this event. Paul is utterly correct when he says we've had a long relationship, successful relationship with National Center. We've had 25 years in existence where we have tried to work collaboratively and convene the practitioners, the policymakers, the service providers, the researchers, all of the different key pieces and parts of data sharing within the public sector and private sector communities. This webinar is only one more example of how we do that and what mechanisms we use. We know this to be a topic of interest. We know this to be a critical asset in meeting operational needs. The exploration on how to prioritize it, define it, implement it, promulgate it, etc., is the sort of the source of this conversation and many more into the future. So Paul and others on this panel today will walk you through various different skill sets, different use cases, different experiences, and models to use for yourselves in the future. And we encourage your participation not only today, but in future events and in participation at the committee level when we get to the more granular level of different priorities and topics and projects. So I thank you very much. I welcome you always, and I pass it back to you, Paul.
Thank you, and it gives me great pleasure to also introduce to you the uh, Beth Clement, who is the President and Chief Executive Officer of the National Center for State Courts. Beth comes to this position from having been the Chief Justice of the Michigan Supreme Court, where she was the seventh woman to step into that role after many years, and also having served previously as the Chief Legal Counsel to the Governor of Michigan, with obviously a wide-ranging set of challenges dealing with this topic of entity resolution in the course of her work as a legal counsel, and also a strong career in the private sector. So having had all of her experiences bringing to this task of organizing and running the National Center for State Courts, we're delighted to have Beth join and welcome you to this webinar. Beth?
Thank you, Paul, and good to see everyone. Good afternoon. As Paul said, I'm Beth Clement, the president of the National Center for State Courts. I'm absolutely delighted to welcome you to this webinar that we are co-hosting alongside our incredible partners at IGIS. As you heard, we're here today to talk about entity resolution, which is a really technical term, but translated into plain English, it means something that I don't think is very technical at all. It means that the data that we rely on to make consequential decisions is accurate and trustworthy. It's about the process of determining when a record that says Elizabeth Clement is the same person as Elizabeth T. Clement or Beth Clement. And that's pretty important to the functioning of our justice system and to the people that come before it. It's our job to get it right the first time. As the former Chief Justice of the Michigan Supreme Court, I saw firsthand how failing to find the same person across cases could lead to problematic and, in some instances, catastrophic consequences. In fact, it was this very issue that mattered to policymakers and appropriators when we requested funding for a single case management system in Michigan that was able to collect and compare apples to apples instead of being overwhelmed by multiple versions of the same versions of names. At NCSC, we recognize the value of better data processes, and entity resolution is at the very core of that. Our recent reorganization put technology and data closer to the center of how we support courts. It is an intentional commitment, and you'll be hearing a lot more from us in this space. In the meantime, I hope today's session gives you something concrete to take back. I leave you in the good hands of our speakers and invite you to reach out to NCSC for us to work together on any of your needs. Thank you so much for having me today.
Thank you very much, Beth, and we appreciate you joining us to kick off this important topic. I'm going to turn over the moderation of our sessions to the National Center to lead us through the progression from talking about the general problem area and the challenges we're facing to the examples of how to solve this problem. And I'm very happy to introduce to you our partner from the National Center for State Courts. Andre, take it away.
Thanks, Paul. Thanks, Maria. Thanks, Beth, for the great introduction and opening remarks. I will be joining as the moderator, trying to keep us, on track and see that we move along and talk about all of the interesting things that we have to talk about today. And in our first segment, we're welcoming Jason Tashia, our new director for technology, data, and knowledge management at the National Center. So just try to deliver on the words that Beth talked about and how we're positioning this as a very important part of our agenda going forward. And he's going to be talking a little bit about the sort of like record linkage problem, why it's harder than it looks, and some of the stuff that we're doing in this space. So with that, I welcome Jason.
Thank you, Andre. I appreciate it. And thanks to IGIS for having us. And I'm going to build off of what Beth was saying about giving us like the why this matters and talking about where the National Center is at and what we're doing about making this goal a reality, where we actually have the capacity to create accurate data in a replicable way by leveraging the best technology for the job. And a lot of the work that Andre's been doing for us among our other great staff is really building the school of practice, I think, that is going to get to this and turn this into a reality. So there's three things I just want to highlight at the top before everybody else today can get more into the weeds. And first, probably near and dearest to the people on this call is jury representativeness. The need is obviously very high. The role that the jury plays in the American justice system is central to how we drew this whole thing up. And yet, as Beth was talking about, making sure that Beth Clement, Elizabeth Clement, and every other permutation between is one single person and not rather three people floating around in the jury system. And this is true across our sectors, it's true across DMV and every other era or every other pot of data that the government has to offer. This is a well-known and trod issue. The errors are common. As Beth has pointed out, names are spelled differently because of input errors or because of a data merge or that went wrong. And what we've been trying to do in the space started back in 2025. Before I joined, this is only my 5th week, but the work that we were doing in the United States District Court of South Dakota really began to put our teeth into the issue as we evaluated the representativeness of their master jury lists, finding all sorts of custom entries, errors, duplications that needed to be deduped. And this was really the hands-on experience that drives a lot of what we're going to be talking about today. And really at the core, even this is a very technical in the weeds conversation, I think it's important to remember that ultimately this is all meant to protect and bolster the jury, this core tenet of the American justice system. Second, we have a lot of interesting work going on with the Department of Transportation, the U.S. Department of Transportation, regarding commercial driver's licenses. While not so much a deduplication effort that needs to happen, it's a question of interoperability between different agencies that need access to the same data. So as you can imagine, drivers are crossing state lines every day to move product and keeping the economy moving. But this creates a massive enforcement headache between federal, state, and local enforcement. Interoperability is hard, and it's been hard for a long time because we've spun up a bunch of different systems that don't necessarily talk to each other. APIs, if they even exist, are brittle. They're not well documented. They don't function in the way that an API should, so you can't transfer the data even if you wanted to. And so this ends up creating a headache for enforcement when it comes to ensuring that we are meeting the requirements for commercial driver's licenses and those that hold them, but also just keeping our highways safe. Like if an accident happens in North Carolina, the folks that are enforcing things in Oregon should be able to access that information if the driver is driving cross country. So in this case, the National Center was recently rewarded some significant work with the Department of Transportation to build the tools that improve that reporting and interoperability, specifically around felony convictions and driver sanctions. The record matching is going to be very much a theme that you're going to be hearing today from Andre and everybody else. And we should be building these systems in a way that not only ensures data fidelity, but then also builds out safer highways for all of us to be driving on. And then the third gets to the last point that I made, is that it's about finding the best technology for the work that needs to be done. Not all of that needs to be AI, but it just so happens that this is a topic where AI is particularly valuable as far as moving the ball forward on these two projects that I've already talked about. So the need here is pretty obvious, is that AI is everywhere all at once, and we don't quite know what to do with it or where it is best suited. AI's capacity is still very jagged. It's very good at some things. It's very poor at others. And that is why the National Center has focused so much on spinning up new capacity, both internally and externally, to build the field. So this includes our free AI sandbox that Andre has really spearheaded for us, which gives a hands-on environment to our members and partners to be able to play with different models in a safe way that ensures that their data isn't being used to train up other systems. We also have the Court's AI Implementer Forum, which is very much a peer learning forum to make sure that folks, as they experiment and try new things, are able to pull from other people's experiences. This doesn't need to happen in a vacuum, and the forum is very much one way that we're trying to make sure that these learnings are cross-jurisdictional and that everybody is moving forward together. And then last is our AI Readiness Project, which helps courts assess where they're at and chart a path forward for them. This includes everything from helping design AI policies to implementation and use questions. And so this is very much the looking forward part of where the National Center is at. And what Beth has already mentioned is that we're investing a lot of time and effort to be able to understand these frontier technologies, how they can be used currently, and where they might take the administration of the courts and the justice system more broadly going forward. This is also collectively to say that we're really focused on methods that are solving real problems. It's not technology for the sake of technology, and not every problem is a technology problem. But as you're here today, the deduplication efforts and the record synergizing that Andre is going to be talking about is very much a tech problem in search of a tech solution. And so I'll hand it over to Andre to moderate the conversation about what's actually going on. So thank you all for being here today.
Yeah. Thanks, Jason. And that was an interesting overview of what the NCSC is doing, and especially to highlight how this is not just a courts problem, it's also actually about the interoperability of systems across, justice partners. Up next, I'd like to welcome Professor Joe Ornstein from the University of Georgia, who's going to join us today to talk a little bit about sort of like different approaches to entity resolution, record matching, record linkage, whatever you want to call it. Professor Ornstein, thanks for taking the time to share your expertise with us today. The floor is yours.
Of course. Thank you, Andre. Thanks to all the webinar organizers, and thanks to everyone for being here today. I'm going to share some slides here with you, if I can pull these up. Okay, so I am Joe Ornstein. I'm a professor in the Department of Political Science here at the University of Georgia. And over the past couple of years, I have spent a lot of time pulling my hair out over the kinds of record linkage problems that Jason was just talking about, and developing some new solutions for how we can perform record linkage and entity resolution in a more accurate and straightforward way. So my goal here with this talk is to give you a broad overview of the field and talk about a couple of different approaches that you can use in order to link records and the drawbacks and the benefits of each one. Before we get into that, a couple of preliminaries. So what are we talking about when we talk about record linkage? Generally, record linkage is a problem that involves matching records across two different data sets. So whether that's taking arrest records and trying to link them with prior criminal convictions, whether it's merging information from different states or different jurisdictions. Some of my work involves linking information from organizations with their political contribution data. And entity resolution, or deduplication, one way of thinking about what you're doing with that is you're essentially linking a database with itself, trying to identify which records in that data set are matches with one another. So whether it's trying to identify when an individual appears multiple times in court records, removing duplicates or deadwood and voter registration rolls, these are all examples of entity resolution or deduplication. And how do we measure success? How do we know if we've done a good job with entity resolution or record linkage? Generally speaking, the field uses two different metrics to try and assess whether or not you've done a good job with record linkage. One is called precision, and the other is called recall. Precision is when you have a high percentage of the records that you've linked together that are correctly identified. And you want to have a high precision record linkage procedure because that means you have fewer false positives. Right? A false positive is bad because you might falsely find that someone who's been arrested has a prior criminal conviction. Recall is the percent of all the correct matches that are out there in the universe that your procedure correctly found. And so, you want high recall to minimize the number of false negatives. And the unfortunate thing is that no automated method can guarantee both perfect precision and perfect recall. Unfortunately, with all the different approaches that I'm going to show you today, there's a trade-off between those two things. And the human in the loop has to decide how they value those different trade-offs. So the first approach that I'm going to talk with you about is called rules-based linkage. There's a couple of different ways that rules-based record linkage manifests itself. The most straightforward way of approaching record linkage is with exact matching. So exact matching is you identify different variables in your data set that you want to match on, and you only link two records if they match exactly on those key variables. The advantages of this approach is that it's cheap, it's fast, it's easy, and it has excellent precision. You're almost always going to correctly identify matches when you do match records together. But the disadvantage is that it potentially has very terrible recall. So a running example that I want to show you here, I've got one dataset A, on the left-hand side that has names and dates of birth, and another dataset B that has names and dates of birth. And if we're using exact matching, we insist that the fields have to match exactly, then between these two data sets that I'm showing you here, Aisha would be the only one that matches across those data sets. Whereas we have Maria here, who has a typo in her name in dataset B. We have James and Patricia, who are listed under nicknames in dataset B. So those would be false negatives. This is a procedure that has high precision, but very low recall. And so when you're dealing with these kinds of data entry errors or misspellings or other kinds of formatting quirks, often a better approach is something called fuzzy matching. And so fuzzy matching is where you define something called string distance, which is a measure of how close two records are together. For example, Maria Lopez and the misspelled version of Maria Lopez, we would say that they are distance 2 apart, because something called edit distance requires 2 different edits to that string in order to get from one to the other. And so the advantage of this approach, which is basically to take these 2 data sets and link records if they are close enough on this edit distance. The advantages are that it's very easy to interpret, very easy to implement. There are free and open source software packages that do this in a very efficient way. But the disadvantage is that it often requires you to make a somewhat arbitrary choice of distance cutoff without always knowing what the implications of that will be. So to go back to our running example here, if I say that close enough means any 2 record pairs that have an edit distance of 2, then I will correctly link the Marias in these 2 different data sets. I'll still miss James and Jim because it requires 3 different edits to get from James to Jim. And I will definitely miss Patricia and Trish because those are very far apart in terms of string distance. Suppose that I decided to be a little bit more permissive and I allowed any records to link if they were edit distance 3 apart. Now I would correctly get James matched with Jim in dataset B, but I would incorrectly link Patricia with Patrick because this one only requires 3 edits from Patricia to get to Patrick. Even though that's any human could look at that and know that that's not the correct match. And so this illustrates this balance, this trade-off between precision and recall. The more permissive you get, generally the higher recall you get, but the lower precision you get in the records that you match. So this leads us into our second approach, which is called probabilistic record linkage. And probabilistic record linkage is a little bit more complicated, but I think it provides a much more principled way of balancing this trade-off between precision and recall. And this goes back a long way. So the workhorse of the probabilistic record linkage approach goes all the way back to Filegi and Sumter a little over 50 years ago. And the idea here is that instead of a rule that provides a deterministic yes or no choice for whether or not you link 2 records together, what we're going to do is we're going to fit a statistical model that assigns a match probability to every single pair based on their string distance. And usually the way that we're going to make use of those probabilities is by splitting all of the record pairs into 3 different buckets. And so there's one bucket where the estimated probability is so low that we're just going to declare those as non-matches. There's another where the estimated probability is so high that we're going to declare that those are matches. And then there is a more indeterminate bucket in the middle where the model says, maybe there's a 50% chance that these 2 people are the same. And that's what we'll call the clerical review area. So this is the area where we are going to apply a little more human review to go and look at these records and verify whether or not they belong together. So to illustrate that approach with the running example here, if we were to fit a probabilistic model on these name pairs, it would probably say that these records here in green are so close to one another that we're just going to declare them matches, doesn't even require a human to go and look at them. And these record pairs over here, like Robert and Aisha, or unfortunately, Patricia and Trish, are so far away from one another that we're just going to declare them non-matches and not even have a human look at them. But this area here in the center, where the records are very close to one another by this edit distance metric, it's a little bit more ambiguous. We're going to kick it back to the human. The human will review it and determine whether they belong together. And the nice thing about this approach is that we can tune those thresholds for how big we want the clerical review area to be based on your desired level of precision and recall. If you really highly value precision, then you can make sure that that you're reviewing a lot of records there at the upper end of the range, so that you can verify that all of your matches are true matches. Right? And this is a lot more flexible than rules-based record linkage, and it's also a very straightforward approach to implement with open source tools. The disadvantage is, like in the example I just showed you, these string distance metrics are still underlying this type of approach, and they still miss matches that aren't simple typos or data entry errors. So things like nicknames or acronyms or translations across different languages, these are things that will probably be very far apart in edit distance, but they still mean conceptually the same thing, like Patricia and Trish. And another disadvantage is that for very large data sets of the kind that many of you work with, it might yield really enormous clerical review areas, right? So it could return several thousands or tens of thousands of observations for the human to go and verify. And so that's where I think there's been a lot of really exciting work over the past couple of years using large language models and generative AI to help assist in the record linkage process. And in particular, I think large language models, things like ChatGPT, like Claude, can help mitigate the two main disadvantages that I just mentioned from the previous approach. One is that they provide improved measures of the distance between different records. And the way that they do that, without getting too far in the technical details, is that LLMs represent text geometrically using something called an embedding vector. I'll give you an example of that in a moment. But this is how a language model understands language, is that texts that are close together in this embedding space are conceptually similar to one another. An embedding distance from these LLM is something that captures semantic similarity, not just the lexical similarity between two different records. And the second advantage that AI can help us with here is automated clerical review. So whereas the probabilistic record linkage procedures might give you tens of thousands of records to manually review because they're in an uncertain range, that's something that we can delegate to machines, because we know that one of the great strengths of LLMs is that they can recognize when something like this abbreviation of William Johnson in a slightly different format is similar to this longer form of William Johnson in a slightly different format. Recognize that they're likely the same person, even without explicitly programming it in order to make that determination. And so one of the potentially exciting things that LLMs can do is, guided by an appropriate model, they can perform a much more exhaustive clerical review than human coders alone. To give you an example of embedding distance and why this might be useful, here's a couple of the names from our running example here. So Patricia and Trish, even though they are very far apart in terms of edit distance, these are, by the way, actual embeddings that I drew from OpenAI's API, squished down into 2 dimensions for you. And in this embedding space, Trish and Patricia are much closer to one another than Patricia and Patrick are, even though in terms of string distance, Patrick and Patricia are much closer to one another. Similarly, we might be trying to decide whether James Carter refers to Jim Carter or James Cantor. A human would be able to recognize that Cantor is a different last name, but string distance just says, well, it's one edit away from Carter, so that one must be the correct one. But embedding distance knows that James and Jim are nickname pairs, and so they're placed much closer together in this space. And so using this as a measure of similarity as opposed to edit distance is going to dramatically increase the accuracy of our record linkage procedure. And so the last thing I'll mention is that one of the nice things about integrating LLMs into record linkage or entity resolution is that they enable something called an active learning loop, where you can fit a statistical model to generate match probabilities between two different sets of records. And then using those match probabilities, we can identify which record pairs require a human or a clerical review to step in and adjudicate. And then we can ask an LLM of our choice to adjudicate those record pairs. And then that feeds back into the original statistical model because we can use those labeled record pairs to refine the statistical model and get a better estimate of the predicted probability of matches. All of this that I'm showing you here, that's implemented in a software package that I developed and released last year. It's called FuzzyLink. And I think the advantages of this approach is that these embedding distances provide a much better measure of how similar two records are to one another, enables both significantly higher precision and recall. But there are, of course, some potential disadvantages to this. So one is that for particularly large data sets, it's potentially quite costly, both in terms of time and money spent in API fees. And it's also potentially infeasible for sensitive data that you don't want uploaded to a public OpenAI API endpoint. And happy to address some of those issues in the Q&A. But my time is up, so I'll simply give you a summary of what I've shown you so far with some of my recommendations. I would say each of these approaches have their own strengths and disadvantages and their own use case. Rules-based is useful for cases where you have data sets with very minimal typos or formatting inconsistencies, and you think precision is particularly important. Probabilistic is useful if you have sensitive data or large data sets with more extensive inconsistencies and typos. And AI-assisted as a last resort, if you have data sets where you have nicknames or acronyms or translations or other kinds of errors that cannot be adequately captured by string distance alone. So I will end it there and look forward to your questions.
Thank you so much, Professor Ortstein. And I think, just try to anticipate one of the questions in the Q&A. I think people are going to ask whether they can, have a copy of the slides as well. So you can think about that for the Q&A part of this. It was a very interesting overview. We were able to see different ways of approaching this problem. Next up, we're going to be hearing about how people are trying to address that in their own context and environments and in how they go about solving this problem. I think first we're going to start off with Samuel Christopher from the Kentucky AOC to talk a little bit about his experience trying to address entity resolution problems at the court, and then I'll introduce the other speakers as we go. I'm just going to ask that we try to keep it under 10 minutes so that we can keep the webinar within the time allotted, and then we have time for the questions towards the end. With that, I'll just invite Samuel to come up and share his experience with us.
Yes, let me share my screen real quick. So, as Andre said, my name is Samuel Christopher. I am a data analyst with the Kentucky Administrative Office of the Courts, and today I'm going to be presenting on a project that I've been working on using Alteryx fuzzy matching to link adult criminal and juvenile data for the Kentucky Court of Justice. So I want to start by talking about the KCOJ's need for fuzzy matching. So in Kentucky, our case management systems for adult criminal cases and juvenile cases are completely separate, and that means the databases are also completely separate. So we don't have a common identifier that we can reliably get between the adult database and the juvenile database to link together and see the criminal history for an individual who may have been in both the juvenile system and the adult criminal system. Because of this, we're not able to create large-scale recidivism reports for youth who are in the juvenile system and the adult criminal system, and that would be very useful to evaluate the effectiveness of Kentucky's juvenile diversion programs. We would be able to create like a background check style thing, most likely for most people, to look at an individual and pull up their record, but we're not able to do that on a large scale to create reports on the effectiveness of programs. So the solution to that is a project to use Alteryx to fuzzy match to get personally identifying information from both databases and identify individuals that match up in both. We used Alteryx because we already had the software and it has built-in matching functionality, so we don't need to get any additional software or learn any new packages or coding languages. So looking at the data points that we pull from each database, we've got social security number, name, date of birth, race, and sex that come from both databases. The adult criminal database does also have driver's license number and criminal history number, which is a serial number that we create here at KCOJ to identify someone's time through the adult criminal system, but it does not connect back to juvenile. There are some other examples of PII that we are not including due to volatility or data quality concerns. Obviously, between a time where a juvenile is in the system versus when they're an adult, a lot of things can change. Height, weight, home address, phone number, hair color, marital status. All those things are very likely to change as a juvenile is an adult later in their life. Also, hair and eye color and ethnicity do not have the data entry rate that we would like to make it worth using them in our model. So I want to go over some of the highlights of the work that I'm doing with Alteryx to prepare the data, fuzzy match it, and what I do after the fuzzy matching has occurred. So to start with the flow here, I'll go over most of the stuff here that I do to cover the highlights, starting with the SQL queries. So there are two SQL queries that are run, one for each database to get information from juvenile and adult criminal. These are structured in a similar format to each other to allow for unioning, and then those two data sources are unioned together with an additional column to say what the source is, whether it was adult, criminal, or juvenile. From there, some of the data is filtered out to allow for an easier time running to speed things up because we don't want to match everything. We don't need to match everything. So entries that have no entry for SSN or name and date of birth, you have to have one of those two things, social or name and date of birth, in order to go through. Otherwise, it's not worth attempting to match in our eyes. Also, anonymized data data that has already been anonymized through expungement or record destruction, things like that. We don't want to keep that going. So in this, because it's not worth trying to match when it's already anonymized. And then like extra white space gets cleaned up. We take out extra tabs, line breaks, HTML tags, invisible characters, things of that nature. The name column is split into first, middle, and last name, and then also the data set gets set to have blanks be turned into nulls. And so at that point, the data is set to be joined back later on. And then the final step before fuzzy matching is to convert the date of birth into a string field because Alteryx does not allow for the fuzzy matching of dates. So talking about the actual fuzzy matching process, Alteryx compares each row to each row. In each row from one set to another set, so we're only comparing adult criminal to juvenile. We could compare everything if we wanted to, but for the scope of this project, we're not. The match likelihood is set based on the best between the Jaro and Levenstein distances for each field. The Levenstein distance is based on the number of insertions, deletions, and substitutions required to transform one string into another, so what Joe was talking about. And the Jaro distance is a measure of the similarity of two strings based on matching characters and any needed transpositions. Each field has a required weight and a match function. The word match function compares words if any are separate, and the character function for matching compares the entire string. Um, Weights determine how important a given field is in matching. The initial weights can be seen in this table, but they are not the final weights that we use in the calculations. At the end, the weights for social security number and middle name are lower here than they are later on because they are often missing, and we don't want to tank a possible result because of missing data. So this is a counterbalance for that. And if rows meet a search and match threshold, they're output as a possible match, and then we would go into the refining section. So we start by removing duplicate matches. Oftentimes a match will show up twice because each side matches to the other side when we compare everything. And then from there, we join back to the data that we had previously to get the information on each matched pair. And then we recalculate the weights to ignore missing values. So if they have a null on either side, the weight is then set to 0 because we don't want to count if there was a weight that was throwing something off. If a null matches to another null, we do not want that because that will improperly boost the match score. And then if there is a null on one side and not on the other, that will improperly lower the match score. Also here, social security number weight is raised to 50 and middle name is raised to 5. And then following all of that, match scores are recalculated with the new weights and some additional refinements. So there's some additional bonuses and penalties that are applied. So if, for example, if the middle name in both has the same first character, there's a boost because oftentimes we see middle initial get entered and nothing else. We also make race and sex be a binary match rather than a fuzzy match because one of the issues that comes up is if you fuzzy match male to female, you only have to have 2 deletions to make that be the exact same string. And so it can output a much higher match than we would ever want. Obviously, they've selected something different from a drop-down menu, and they did not mean 75% match or whatever. So we would not want that. And then also there's bonuses and penalties for if certain parts of the date of birth match up, the year, day, month. From there, filter is run again to remove anything that is missing either of the SSN or the first name, last name, and date of birth. You have to have at least one of those, otherwise it filters it out again. And then the overall match score is calculated based on the changes made to this point, and additional subtractions to the overall score are made for certain fields being missing, so like social and the name fields and whatnot. Finally, there's some steps taken to set the column to get all of this set for viewing. So some changes with rummaging and visuals in mind. Match scores are set to null as a visual indicator for one or both sides being missing, and the fields are reordered for ease of use, and the data is sorted, things like that, just to help with viewing. So I want to sum up by talking about the advantages and disadvantages to this method. As I've discussed, one of the pros is that we already had the licenses for Alteryx, so we didn't need any new products. We can load data directly from SQL and process it in an easily editable, visually formatted flow, and the flow is effective in identifying likely matches. However, the drawbacks are that Alteryx has no fuzzy matching for dates, and we have to do all that post-matching refinement to deal with null entries on one or both sides and attempt to get everything as matching as best as we can after the fuzzy matching module has already done its work. Also, though, the biggest issue is computation time. For example, if you had 5,000 rows on each side, it would require 25 million comparisons because it's doing 1-to-1. Adding just 10 rows to each of those sets would result in 100,100 additional comparisons. So that's why we haven't been able to upgrade this to scale yet and to do large-scale projects with it. It does seem to be working in small scales, but in large scales, we haven't been able to get it to work with the amount of computation time that is required. So this is still a work in progress. We are improving on it where we can, but I am very happy that I was able to come and talk about what we are doing here in Kentucky, and I look forward to any questions that you all may have. Thank you for having me.
Yeah, Yeah, thanks, Samuel. And I think, one of the interesting things that you brought up is just maybe another example of trade-offs you have to make along the way, touching, maybe expanding a little bit on what Professor Ornstein was talking about, not just like looking at the, metrics of, success, but also just like decisions you need to make and things you have to deal with when using these types of technologies. With that, I'm going to invite, our next speaker from Mark 43, Kevin Prey, to share also a little bit about, these technology-based entity resolution approaches. The floor is yours, Kevin.
Okay, great. I'll go ahead and share my screen. And all right, excellent, excellent. So, Mark 43, we're a cloud native, or the first cloud native CAD records management platform in the industry. And all the the previous presenters are gonna they're gonna sound a lot more smarter than me because I'm a little bit more of the functional arm or the tip of the spear, where the the end user out there is doing a lot of this action, right? So that's what I'm gonna focus on. And then I'm also gonna put a little focus into where we're at with entity resolution and where we're going, and where AI kind of falls into Mark 43. So again, it's tip of the spear, and looking at the slide, right? We're transitioning from just kind of marketing ourselves as just functional CAD and RMS to really looking at the ecosystem of what's going on right now in public safety. So with CAD and records management, there's several endpoints where having to identify the right person drops in, and these are very constant conversations that we have to have with every agency that we're working with, and that we're constantly working on improving our cloud native multi-tenant platform, which again, every improvement that we do is going to affect, every agency. So we have an economy of scale with how we push out and, improve and again, continue to build on the platform. So, on the CAD side, look, you're having next generation 911, which might have identification of people through caller data. We can get into, sensor gunshot detection, which isn't necessarily people, but in our platform, being the records management, case management platform, we have an entity-based system, which, vehicles, guns are highly important to that. And the again, the metadata associated with that, the serial numbers, the calibers, the information, the ammunition that is found on the ground, and ties into that and how that integrates with identification systems. So again, just taking a step up, being the records management CAD platform, we're just the endpoint. We are the system of truth, system of record for all of that information. So again, making sure that we have the right entity, the right person identified, and that we are building a user interface and a user experience that promotes positive identification behaviors is of the utmost priorities to us. And this is not just for documenting right information, right? It's officer safety. It's in the future being surface that information when the officer's on a call to a certain location. It's investigations, so it's finding information and linkages between citations and previously arrest records and felons and recidivism and information that comes over from jail management or from court or warrant side of the house. So solving crimes, and then it's workforce, right? It's making sure that we lower recidivism and making sure that we identify the individuals that can be rehabilitated, and making sure that services or victim and vic witness services and persons of interest services are being accessed correctly. So when you look at this, just think of the state CJIS systems, the fingerprint scanners, the facial recognition systems, not necessarily that Mark 43 is doing, the information that officers have to take from the field, the arrest reports, and pretty much that 75% of what the end user is doing on a regular basis. And think about the mobile applications, so scanning driver's licenses, taking pictures, things like that, and then building that into the workflow and how that identifies the correct people. So, all right, taking a step back, one of the good things here, and I don't want to recreate the wheel, but I'm going to show a little bit of Mark 43, right? And this isn't a huge sales pitch, but I'm going to go into a little bit of how we handle this right now and what we're looking at in the future. So again, Mark 43, records management, computer aided dispatch. On the left side here, you're seeing different modules, and right here you're seeing arrest reports or recent arrests and information going on. But as the officer documents information, and I'm getting into the report writing experience right here, there's crime information or information that flows in from the event or from the incident. So one of the key places, and again talking about workflow and enforcing positive behaviors, when you go to add a suspect or add a person of interest in Mark 40, and this has been from the beginning, you have to search, right, and this is going to sound very simple, but in a lot of other platforms, and just the way folks think, it's a spreadsheet, just put the information in. But 75% of the time you're dealing with frequent flyers, regular individuals, or individuals that you do have data on in third-party systems, or you might have data on from previous interactions and crash reports. So I'll use myself as an example. And then, one of the previous presenters talked about fuzzy matching. So, the officer gets in here, they're going to do name, date of birth, name, address, right? And if I misspell it, Kevin Frey instead of Kevin Fry here, we have those fuzzy matchings, and or if I misspelled Kevin free and use an E instead of a Y. We also, we use that core framework of Elasticsearch or AWS search, which is what we're expanding to right now. And then you'll see Kevin Frey here. And then if there's any, matches or one-offs right there, you get that. Suggested profiles, this would come in from, again, whether it's a license plate hit or a person hit or a scanned driver's license from the event. You also see right here, create new profile. So we did not allow the end user to just circumvent this whole process and create this from scratch. They had to actually search for a name before you created that. So again, lowering on, just via, again, workflow and via, positive, user enforced development practices, being able to, make sure that we're funneling a lot of that bad data ingress. Then you have add from universal search. So when you start talking about third-party integrations, I said you could scan driver's license plates from the CAT event, but we're also pulling this into the RMS too as well. So if I wanted to, search into, somebody's last name, search their license plate, search their driver's license, or start to plug into public databases, the Reuters, Thomson Reuters, or LexisNexis databases, we can do this from universal search. And I have that up here too as well. So if I wanted to put in a name here, I have an example name. This is all dummy data. Boom, hit that, pick what databases you have, get the hot hit that returns, right? And you can see that in CIC information. You can see the DMV information. We can pull in DMV photos and then use that to update, the master entity or update, the report writing experience in the flow of the work. So again, just really bringing it at the time that you're having those interactions and enforcing guardrails and validations. You're going to get good data in, great data out, and you're going to lead to better outcomes and more positive outcomes. Other areas as well, the arrests, right? So you have AFIS live scan, that was a little bit talked about the court systems a little bit earlier. That's very common. There's also running into a lot of fingerprint scanners in the field. Some states, some regions, some other countries that we do markets in, those fingerprint scanners are connected to their state, their national databases. In the UK, we're there, P&D. I've been seeing this a lot in Florida too as well. So just being able to, as you're in that report writing experience and you're adding charges, be able to go through that positive identification again, right there at the tip of the spear. Other things in Mark 43, right? The whole platform is built on an entity resolution system where basically, being able to relate entities to, locations, to relationships, to other disparate data, whether it's unstructured or structured data within the platform. The unstructured side comes in as we start to layer AI on it and start to, pull up more information. And then we have the idea of like a wheel and spoke model. So as you have an interaction with an individual, right, it is that person, it is that context at that individual point in time. So this is Randall Jamison Flagg. He was arrested at a certain point in time, but what is his master information? What does he look like holistically, up to date? And after you have those individual interactions, the most recent interaction is what surfaces to the top and is what, happens. So, right now I have a beautiful man bun. You arrested me last week. It was, nice yellow flowing hair. You grabbed me this week. I have purple hair. My master entity is going to say I have purple hair, but that arrest report last week will always say that I have my yellow hair here. And again, via, data aggregation or, third-party platforms or within Mark 43, you're going to be able to surface, all the linkages. And we're getting into, what we're going to call cluster profiling, but being able to really, really look at, the ecosystem of integrations that we have and provide, linkages from a master entity perspective or even from a link analysis perspective, right? And being able to layer on whether it's location, GIS data, or you're layering on, firearm or vehicle related data, right? And, this is some of my big bad guys. So this is going to get, very, very muddy here, but being able to, tag and have all those linkages very easily surfaceable. And then finally, look, AI is out as here, and we're talking about deduplication too as well. I mean, within the platform, right? Like I said, there's workflows to where you're identifying persons, you're identifying them, throughout the life cycle of what's going on or throughout the life cycle of the event. But bringing back into some future concepts, I wanted to show slide this one right here. So, getting into AI assisted reports. And again, like I said, there's going to be multiple places where the data and the identification needs to happen. So as you're writing the report using AI, using all of that data, which we're the rightful owner of because we're the centerpiece of this multiple ecosystem, being able to give suggestions to the officer, to the end user, with relevancy scores. Additionally, as I chime through this, other things, like I said, structured and unstructured data. So the body worn cameras, the license plate readers, pulling that license plate, automatically running it, parsing that data that comes in, getting the owner of that, automatically running it, right? And, again, being able to assist the end user through the identification there. Scrolling to a few other things, like I said, investigative profiles. So being able to position, the correct identification and looking at multiple systems and surface this information, whether it's an investigator or it's just, someone that's, looking at, specific information to solve a crime or a person of interest, or again, VicWit services, right? Being able to surface that, whether I'm using, large language models or I'm just using, a very well fleshed out, objective or entity-based database. But yeah, this is a little bit of where Mark 43 is getting into. I wanted to be quick and dirty today. I didn't want to pull too much out. Could have pulled my mobile application out, scanned some driver's licenses, but ultimately, duplication, deduplication, making sure you have the right person, being the reliable system of truth, and then having a system of toolage over the top of it that makes sure that you're surfacing the right results and with the right relevancy to your end users is where Mark 43 has always been and is where we're going to continue to go. Good data in, great data out.
Thanks, Evan. And I think, that was maybe the most important takeaway because you talked a lot about the quality of data and enhancements that you can do to a particular, small set of data fields that then can, be augmented and maybe used for sort of like the clerical review step of the process, maybe as Professor Arnstein talked about. So I think that's all great information. With that, I'm going to invite Chandler Hall from EY to talk a little bit about also their approach to this. And then, after him, we have just another speaker before we go to the Q&A and try to think about how you can participate and help us do this. With that, I will invite Chandler to our virtual podium. Yes.
Thank you, Andre. Well, hey everyone, I'm Chandler Hall with the EY Unified Justice Platform, and today I want to focus specifically on how we at EY approach entity resolution within the context of our justice platform. So I'll keep it tight since the group's interested in entity resolution, but if anyone's interested in learning more about the platform, which I will not be covering in depth today, feel free to reach out to us and we can certainly answer questions or curiosities. So at a high level, entity resolution is one of the core enabling capabilities that you see here in this abstract of our platform. So along things like the knowledge graph and the unified data portal and event-driven architecture. So it's, entity resolution is really what allows us to connect data across our agencies like the sheriffs, courts, probation, district attorneys, right? And actually makes that data usable in a unified operational view. So really, it works in concert with the rest of our platform. The standards-based integration brings a lot of our data together from across agencies. Entity resolution connects these identities across systems, as we've been talking about here as a group. And ultimately, our knowledge graph as part of our platform gives that connectivity and those resolved identities, the context of having relationships and tied to different events and history and different relationships of that manner. So instead of just moving the data and resolving the data, we're connecting it. We're creating this entity or even case-centric view of activity across the justice ecosystem. So that's the context. And entity resolution is certainly a foundational piece of how our justice platform is delivering value and in exactly where we want to focus today with the group. So to get right into it and to talk about our approaches with the justice platform. So we have two approaches. So approach number one is when PII, identifiable information can be shared. So this is an approach that most of us are familiar with, and it relies on scenarios which sharing PII is permissible and feasible, and you have those access to those identity attributes which are so critical to perform entity resolution. So at EY, within that approach, we use sensing actually as our tool or mechanism for entity resolution, combined with a knowledge graph to provide that relational context, as I was saying. And so typical scenarios where this works well, statewide integration across courts, a county level justice hub with shared governance across multiple agencies. So we have a client in California, so a large county in California with this particular type of model, or task force or fusion centers, which are contributing into shared justice ecosystems, like with another client of ours in a major metro area. So in these environments, entity resolution is strong because you're working with direct identifiers like names, date of birth, social security, you name it, right? All those identifiers which make a person unique. And so where a challenge still exists and where we're addressing most recently is approach number 2. So approach number 1, you might be familiar with. We're certainly doing this in a lot of places, and it's important and still challenging, on an everyday basis. But approach number 2 is where we're trying to solve for a little bit. So that's where PII cannot be shared or not as easily shared, right? And so these are circumstances where that readiness to share PII in bulk is not they're not ready. The clients, these agencies not ready. The governance models maybe don't support identity level integration at the given time that you're working with someone, or kind of simply agencies can't or are not willing to expose that sensitive data across certain boundaries within their environment, right? And so, but yet entity resolution still would have a value if we were able to address and solve that circumstantial problem. So, a few examples, right, would be just where we have cross-jurisdiction collaboration where policies or agreements or memorandums don't align and then don't permit this feasible sharing of data. So in those environments, traditional entity resolution approaches maybe not viable, but approach number 2 that we're working on here would make that viable. And so this is where we're bringing kind of a new approach, which we are calling Pearl. So that's a privacy enhanced record linker. So this is our approach to enabling entity resolution in those places where without requiring PII to be shared in that sensitive manner. So the goals of approach number 2 is simple. We want to preserve the value of entity resolution while respecting the privacy and governance constraints of certain justice groups, agencies, you name it, so that we can still bring that value. And so let me show you on this next slide quickly how that fits into what you may or may not already know about the EY Justice platform. So what you're seeing on this slide is actually just a screenshot of maybe a few iterations ago of our existing Justice Hub within the Justice platform. So this is our single pane of glass outcome powered by the traditional approach number 1, right? So this is where we resolve identities across systems. We build out that entity-centric view for a person or for a case here and surface it through this unified interface. So users can see this consolidated view of an individual across agencies, cases, interactions, you name it. And so this is what we believe success looks like when PII can be shared, because it's proven, it's operational, and many of us have working solutions to bring something like this. And so what we're addressing now with approach 2 is how do we achieve this same outcome in environments where the underlying data sharing is not as easy or not as feasible for a variety of reasons. And so that's exactly where that Pearl concept I just introduced extends the entity resolution model. And so only a slide or 2 more here that I want to elaborate on Pearl. So we'll keep it super high level. We'll have a ConOps slide after this, and we'll just talk about the value, and we can certainly get into a technical level of detail in a Q&A or at a later time. But at a high level, this is how Pearl works. So step 1 is really about the local agency processing. So when each agency processes data within its own environment through a privacy layer, and the important takeaway here is that raw identity data is never leaving their system in a usable form because it's sent in a encrypted manner to the next step in this Pearl process. So step 2 is creating a privacy preserved linkage from that encrypted source system data. So even without those direct identifiers, readily available, the system can determine which records correspond to the same individual and preserve that privacy through encryption. And then step 3 is consumption. This is maybe the easy to understand part, right? Once we have made like a de-identified graph of resolved linkages in step 2, we can feed that into analytics platforms, our own justice platform, APIs, dashboards of all kinds, so that this linkage can be made, privacy can be preserved and used in different platforms. So really the operational workflows can either remain intact or become intact, if you'd like to say that, for places which maybe haven't been able to bring entity resolution so easily because of constraints of their own circumstance. So the key point here is that entity resolution, ER, is still happening, but just in a way that can work within a constrained environment. So lastly, this is our second to last architecture slide. This diagram is showing a little bit more in detail how it's working, right? So each agency has what we call a privacy enhancement gateway, which is keeping the sensitive PII processing local. It applies privacy controls. It governs what leaves its own system, right? So they have control over this. Those outputs feed into Pearl, which is our privacy enhanced linker, right? We're building a de-identified entity resolved, knowledge graph. Those resolved links become available for consumption, like I had mentioned a moment ago, in a variety of means and methods. So this becomes extremely valuable, we think, in cross-jurisdiction environments, federated models, other privacy-constrained, initiatives which want to bring ER but don't know how because of their limitations around it. So, last slide. Just want to close on what's valuable here with Pearl and our second approach, but certainly we have 2 different ways to do this. It's deterministic and explainable. It's using those privacy preserving techniques, and we can certainly kind of get into the detail later, but we don't want to take up too much time. It's configurable to a use case, so you can kind of determine whether you want to match entities or persons, right, optimistically or pessimistically, and we can elaborate on that, at a later time. And it can operate in a highly controlled environment or context. So the key takeaway today, if I were to have a key takeaway for this group, is that we have 2 approaches to ER. Approach 1 is when PII sharing is feasible, because PII is available and can be used and can be shared, right? Second approach is this one, where we can enable entity resolution when PII can't necessarily expressly be shared and is in a constrained environment. And importantly, it allows us to deliver the same kind of unified operational view that I had shared an example of in the Justice Hub when the data sharing is not as easy. So I think that's my time. Trying to keep it short. But Andre or Shabankar, if you have additional notes before I close out, just feel free to chime in.
Yeah. No, thank you very much, Chandler. We're going to move on to our last speaker, Ray Chang, so that we can cover everyone and then make some modifications towards the end so that we can, have a good conversation in the last 10 minutes. But I would just say that it's great that you touched on privacy enhancing record linker. We had that as the future. So if we had time, we were going to be discussing that. We kind of had it called privacy preserving record linkage, but it's great that you brought it up. So that just kind of points us to some of the new challenges and the things that we should be thinking about. With that, I'm going to hand it over to Ray Chang to talk about AWS entity resolution. Right there, it's in the slide. So thank you, Ray.
Sure thing.
Yours.
So thank you very much, everyone, for the opportunity to talk with you for a few minutes about this really fascinating topic. My name is Ray Chang. I've been a solutions architect with AWS for 8.5 years or so now, partnering with our most strategic customers in the public sector and the state and local government segment, especially. And so in that time, if anything sort of come to light from my experience, and I think we heard Jason allude to this earlier, is that entity resolution is, as a problem or as a problem space, is cross-cutting across virtually every aspect of government operations. But we feel it pretty viscerally in justice, right? We've got multiple distinct systems that we've talked about today. You might have court management systems, record management systems, booking systems, prosecutorial databases, et cetera. And across all of these, you're going to have a measurable risk of events like typos on name entry or transposed elements of dates of birth, multiple aliases, conflicting SSN information being provided, etc. And since this is the justice and public safety domain, the impact, right, of these unresolved entities goes well beyond a simple data integrity issue or a bookkeeping annoyance. We become at risk for outcomes like missed warrants, duplicate dockets, maybe even the wrong individual being released, etc. So, how do we approach this problem? In the AWS platform, we have a managed service called Entity Resolution, which provides managed building blocks to address this record reconciliation issue. So, for example, there's the capability for your organization to author rules, right? You codify your matching policies. For example, you might decide you need exact matches, as Professor Ornstein was talking about earlier, as one of the approaches, exact matches on certain fields combined with fuzzier heuristics, like we heard others already speak about Levenstein or edit distances or Sondex encodings. I think that was something that was brought up in one of the Q&A items, but you might employ fuzzy approaches like that to handle typos or misspellings or common name variations in your data. Alternately, you might employ measures like cosine similarity to tackle different punctuation schemes, different presentation formats for elements like mailing addresses or organizational names. And these rule-based approaches can then be also combined with what are so-called ML-based approaches, which leverages a machine learning model pre-trained by AWS, which can iterate through your data sets and then to flag certain matches as being potential linkages between different data sets. And this also maps to sort of approach two, if we recall what Professor Ornstein presented, of a probabilistic matching method where the service will return a numerical interval of confidence in terms of, I thought this record matches this, and this is my percentage confidence. You know, you might, depending on the threshold you've set, that might be something that gets flagged for manual adjudication afterwards. Worth mentioning also that the service allows for the capability to integrate with third-party data sources such as LiveRamp or TransUnion if you have utility or need to be able to, let's say, verify the data elements you have and or maybe enrich them with additional data elements. Maybe not a common day-to-day use case for this space, but worth letting you know that the functionality exists. And then perhaps finally, the most important is the capability for the service to have workflows that essentially map identifiers native from one of your information systems to another, right? So essentially you build a lookup table that's the collection of unique identifiers in the CMS, in the RMS, in the booking system, et cetera, for one logical entity. Also kind of worth editorializing here. I've mentioned these are building blocks earlier. None of these insist on being present, and as a collection, don't need to all be there, depending on what your current architecture is or what your solution portfolio already looks like. If you're leveraging some other solutions to perform some or all of your entity resolution, these can be plug and play and complementary motions with all of this. So let's look at a grounded example of entity resolution in action. We mentioned we're going to have multiple systems, more than likely, in our environment. There may be records across these multiple systems that might correlate to the same logical identity, but as we know in real life, they're going to have slightly different variations in data elements. So for example, in this case, you can see that there are casing changes or completeness variations in the name element across different source systems. And one of the systems may in fact hold a date of birth in which two of the digits were transposed. So these are all realistic things I'm sure we've all seen. So enter our entity resolution workflow. In this particular example, we've authored a particular rule-based matching. It's given the label of number 3 here, but it's solely arbitrary. And maybe for our organization, we define our matching policy as we're going to evaluate that Levenstein distance between the name fields. And if that is below some arbitrary threshold, and we see an exact match in the date of birth field, so that's the combination of exact and fuzzy that was talked about earlier, then that rule fires. And based on that rule firing, the service declares that these two records are indeed linked. But now we can also combine that with a machine learning based matching workflow in which that model we talked about earlier examines that third record from the booking system, sees the date of birth. It's not an exact match, but based on its similarity, it produces a confidence interval that isn't 100%, but is pretty high that there could be a linkage between that third record and the rest of them. So now we've combined exact and probabilistic methods, and the outcome allows us to fairly confidently build one of these lookup mapping entries that correlates the unique identifiers across three, or in real life, it'll be many more than three, but the three different systems all mapping to the same logical identity. And at AWS, we're constantly improving and iterating on our services based on customer feedback. So, of course, in this year, 2026, there's some new goodies that are available to help make it easier and faster to get started with entity resolution in AWS. A deployable reference architecture that combines AWS Glue, which is our our managed data integration platform for secure visibility to your data, combines it with Amazon Bedrock, which will provide managed access to large language models like OpenAI, like Claude, like Amazon Nova, et cetera. And in this way, you can leverage the power of generative AI and language models to analyze your data and maybe based on the composition of your real data, come up with an initial draft of matching rules to use. It's also worth mentioning you can also use the same workflow to then address some of the concepts that Professor Ornstein was talking about with approach 3, where you might run that ML-based workflow from earlier. We get that set of confidence interval matches, and the ones that are too low, we can throw away. The ones that are too high, we accept. And then maybe the ones in the middle, now that we've whittled our data set down to something more manageable, we can send it through a generative AI model for analysis. Because of the domain that we work in, obviously governance is a critical consideration, right? So the data involved in these workflows are always going to be encrypted with AES 256 strength envelope encryption through our KMS or key management service. Also enabling granular on-demand record level deletion of the matches for compliance, retention compliance specifically. You heard Chandler mention the importance of observability and auditability. The service by default emits job execution logs that capture the full history and detail of all of the matching workflows, including exactly which of your rules matched to trigger the flagging of that as a linkage, as well as if you were running that machine learning based workflow, all of the specific numerical confidence intervals that were associated with the match are returned as well. For data in transit, the service supports FIPS compliant endpoints as well as encryption ciphers and utilizes a network service called AWS Private Link to keep all of that data traffic within your specific AWS account and in the specific AWS region in which the data resides, so nothing ever leaves. And finally, from a cost perspective, utilizing this service is straight pure utility pricing per record based on the volume that you actually process. There's no need to provision capacity, no minimum infrastructure to provide, nothing idle to pay for, so to speak. And finally, if there's 3 key takeaways I want everyone to be able to leave with, number 1 is you don't have to build your entity resolution functionality from scratch, right? You can leverage a provided service. You've already heard some of my fellow speakers talk about some great ones out there already, but it can be a managed primitive for you now. Now, depending on the bespokeness of your use case, you might still need to, but don't default to that. Number 2, there's a lot of tools in the bag when it comes to addressing the various aspects of challenges in the entity resolution space. Pick the right tool for the right job. Pick those deterministic and auditable rules to codify your matching policies. Use approaches like machine learning based matches to surface that long tail of weird variations maybe your current library of rules don't capture, and use that over time to constantly improve your library of rules. And finally, number 3, use the generative AI and large language models, right? Use that novel technology to get a head start on baselining your initial set of rules. It's the starting line, not the finish line, right? Ultimately, we as practitioners, we still own and approve all of the rules and configurations we deploy into our environment. But hey, why not use generative AI to jumpstart and accelerate that process? And with that, thank you very much for the time. If there are any questions or inquiries about how we can tackle these and other interesting problems in AWS, please don't hesitate to reach out. Thank you.
Thank you so much, Ray. And I liked that your last slide was, maybe takeaways that would also help people get started in this process. So that kind of covers what we wanted to talk about in segment 4. And in the interest of time, I think we're just going to skip segment 4 and then just give you a few, announcements and notes. But also, if you have questions, just send them over so that we can address them. We were able to cover most of them throughout the seminar, so I'm not too worried if we don't get to Q&A. But thank you so much to all of the panelists and everybody who's attended this webinar so far. I think an important point for us is that we're not here just to present, but also to listen and learn. And we would love to hear from you about this webinar and many of our other initiatives. So I think the first question we have for the audience, and then if you can, feel free to reach out to us in whichever way you think best for you, is whether we do need to develop standards for entity resolution across the justice system. So based on the things that you've seen today, on your experience, what are your thoughts? Should we develop our standards, top priority in the space for us to be considering? Yes or no, and then we'll start thinking about this. Should we produce white papers and best practice guides? So should we be thinking about those as well and share the knowledge, not only from the session today, but also maybe further work that we do in the space with the group? And question number 3 for you would be, are there technology pilots or proof of concept efforts that we should pursue? So things that you've seen or you were developing yourself, maybe you decided to go rogue based on race, takeaway and decide to build your own. What are sort of like the things that you've seen that you want to pursue? And finally, how can IGES and CSC bring the most value to our members who are grappling with this issue today? So if you, are trying to work in this space, solve problems in your agency, how can we best support you? So, this is sort of our way of, advancing our mission and trying to help you achieve your goals. Your participation in the committee meetings is very greatly appreciated and deeply valuable. And all of these insights are used to share knowledge and see that everybody advances in the space. With that, I'm going to hand it over to Paul to see if you have any last comments or like us to just open up for questions, whatever you think is best for us right now.
Well, thank you, Andre. I want to thank all the presenters for presenting the various options in this. I think there's some commonalities that we could see from all these presentations. One is that this whole field is an emerging technology. We're learning how to use AI. We're learning how to use machine language. The examples that you've seen are progressing the state of the art. This goes a long way from the early days when in the justice world we used Soundex as the only basis for making comparisons, according to the FBI's original notions of how to do this. And we've advanced to the point where everybody should be having a common equivalent of a master name index and ensuring that you can't enter a name into the system, your enterprise system, without it being recorded and being accessible. So there's much more work to do in this whole regard, and I think we're very eager to have your input about what do we do next on this topic. This is not the end of it, and I'd really like to turn the podium over to Deanna a little bit to talk about, from the perspective of the IGES Court Technology Committee and the work we're doing with the National Center, to talk a little bit about some of the next steps that we're considering and get your input just before we close this meeting. Deanna, can you summarize, please, for us?
Yeah, so first of all, I just wanted to say thank you to all of our speakers. I thought this was an absolutely phenomenal webinar. I learned a lot today, and I'm hoping that our audience did as well. One of the things that I do want to bring up is, we are really taking an active effort to collaborate with the Information Architecture and Technology Committee, as well as aligning ourselves with NCSC. Within the Court Advisory Committee, we really want to bring value to our customers and our users that we interact with on a day-to-day basis. And so we would really love to have participation from each and every one of the solution providers, from agencies, so that we can actually, really understand your true needs. Because the way that we develop and create value to you is by listening to you. So what we would really like, if you would like to participate in our committees, we would welcome that. You're more than welcome to reach out to myself, reach out to Paul. But most importantly, we need to hear, what you're trying to accomplish and the roadblocks or pain points that you are dealing with today, so that we can actively find solutions for them. So that's pretty much, what I wanted to say. Thank you.
Thank you, Deanna. And I think we've run out of time, Andre and Deanna, and I really again want to thank everybody for participating in this webinar. We like to adhere to the schedule that we promised you, so we'll draw this to a close. But you're more than welcome to provide feedback to Deanna or me or Maria or Beth or Andre, anybody that you care to write to. It'll all come back to put into the pot of how we can be helpful in the future to help resolve some of these issues. And we're not going to close off this story. We're going to be looking at ways we can help move the field forward, as both in the terms of the provisions from the technology community and the needs of the practitioners. So that's really what IGES is intending to do. We look forward to all of you participating in our community forum in Florida coming up in a couple of weeks, and the AI Summit in September at the IGES Institute in Washington, D.C. All those details are on the IGES Institute website for you to look at, and we look forward to that. And with that, I think we've reached our appointed time. So thank you all for attending, and we'll close that webinar for today. Thank you very much.